Welcome to Fun with Physics.
On this episode, we'll be talking about waves.
Waves are everywhere in nature.
Sound waves,
Visible light waves,
Radio waves,
microwaves,
water waves,
sine waves.
Madigan?
What is a wave?
Great question, Madigan. A wave is a disturbance that travels through a medium from one location to another.
Yo, teach! What type of waves are there?
Well, Camilla, one type of wave is a longitudinal wave. This is the same type of wave that we use to transfer sound. The medium particles vibrate parallel to the motion of the pulse. Here's an example. A second type of wave is a transverse wave. In a transverse wave, the pulse travels perpendicular to the disturbance.
So, what does a wave, look like?
Let's take a look at the anatomy of a wave. The maximum displacement is called the amplitude. The amplitude of a wave is the maximum height of a crest or depth of a trough relative to the normal or equilibrium level. The period t is the time required for one complete cycle, back and forth, and the frequency f is the number of cycles per second. They are related by f equals 1 over t. In a transverse wave, the oscillations are perpendicular to the direction in which the wave travels. An example is a wave on a string. In a longitudinal wave, the oscillations are along or parallel to the line of travel. Sound is an example. Great job! Class dismissed.
But I really want to know more about waves and vibrations.
There are probably some Khan Academy videos on that.
That was a cool lesson, but I still want to know more about waves.
Me too.
After some careful research, we found some really cool facts about waves. Let's dive right in. Welcome to the wonderful world of waves.
When a vibrating system is set into motion, it vibrates at its natural frequency.
The natural frequency equals 1 over 2 pi times the square root of k over m, where f0 is the natural frequency, k is the spring constant, and m is the mass.
However, a system can have an external force applied to it that has its own particular frequency. This is called a forced vibration.
If an external force is applied, the mass then vibrates at the frequency of the external force, even if this frequency is different from the natural frequency of the spring. Resonance is a process in which an object's natural frequency is amplified by another object with identical natural frequency. Wind-induced resonance is the reason for the Tacoma Bridge collapse in 1940. In this case, the identical frequency was caused by wind gusts blowing across the bridge. The wind blowing across the bridge created pockets of high and low pressure above and below the bridge. You may recognize that this is the same scenario that happens in Bernoulli's principle. This produced violent oscillations, or waves, in the bridge, causing it to move up and down and eventually collapse. Here's a clip of footage taken moments before the collapse. let's talk a little bit about wave motion. Before I go any further, it's important to remember that while waves are moving oscillations, they're not carrying any matter. In a mechanical wave, there are two types of velocities. They work perpendicular to each other. So, as you see here, you have the wave velocity, which is going this way, but the rope is actually going this way at this point. So the rope is going up or down, while the wave is always going this way. Now, I bet you're sitting there asking yourself, but Sydney, what is the formula for the velocity of a wave? Well, let me tell you. Velocity is given by this here equation. Velocity equals wavelength over time period.
My phone's vibrating. I must have gotten a text. That reminds me, the source of any wave is a vibration, and is a vibration that propagates outward and thus constitutes a wave. The wave may be a pulse, which is a single crest, or it may be continuous, with many crests and troughs. Vibrating objects act as sources of waves that travel outward from the source. Waves on water and on a string are examples. Here are some examples that you see every day. Sirens created by Camilla's hand made vibrations which caused waves in the water. In this case, sound waves and vibrations are working together.
So what do waves do? Waves transport energy from one place to another. As a wave travels through a medium, the energy is transferred as vibrational energy from particle to particle of the medium.
When a wave strikes an obstacle or comes to the end of the medium it is traveling in, at least a part of the wave is reflected. This is what occurs in an echo. The angle of reflection equals the angle of incidence. This is the law of reflection.
That concludes this week's episode of Fun with Physics.
Bye for now. See you next week. The velocity of a wave is given by this here equation. Velocity